In this video, we'll be talking about Amazon's Elastic Load Balancing service with EC2 instances. Say you have a popular web service running on AWS and you see the traffic to your web page spiking and increasing on average every day. There's a limit to how big of an instance you can assign to your web server. At some point, it might make sense to deploy multiple web servers in parallel to manage your traffic. This is where ELB comes in. ELB is a gateway/router interface. It sends incoming requests from the interface to an EC2 instances pool that you define, and ELB distributes the requests from clients to all of the servers equally. Here's a figure of ELB and how it works. It's simply a software service that Amazon provides that equally distributes incoming traffic load to a pool of web servers that you define. Let's look at some of the ELB's features. ELB is a web service that allows you to distribute traffic across multiple availability zones. This allows you to increase redundancy. So within a particular AWS region, for example US East, you can define a load balancer to send requests to instances within multiple zones inside US East, such as US East 1, B, A, B, C, D, etc. The benefit of this is that if an entire data center happens to go down, an entire zone inside a data center happens to go down, then your website is still kept alive by the remaining instances in other zones. ELB also allows you to automatically check the health of your instances. You can define a particular operation that ELB must perform periodically to determine whether an instance is healthy or not. And if there are instances that don't respond in time to this checkup, ELB will automatically blacklist those instances and send requests to other instances in the pool. And ELB also integrates pretty well with auto scaling, so this allows you to grow and shrink your instance pool as required. And in fact, this is something that you'll be doing later on in the projects. Let's take a quick look at a case for ELB. Then this comes from Airbnb, which is a community that allows property owners and travelers to connect with one another. I'm sure many people might have heard about it. Within 4 years, Airbnb has become quite big, has hundreds of employees and operates in nearly 25,000 cities in 192 countries. Airbnb is a classic case of a startup that grew pretty fast. So they use Elastic Load Balancing, and they use it to distribute their worldwide traffic among a dynamic pool of web servers in multiple AWS regions. And they've reported significant savings when compared to static provisioning. Okay, let's do a test of the Elastic Load Balancer. For this test, I have provisioned two T1 micro instances, ELB Demo 1 and 2. Both are running the Ubuntu AMI, and both of them have been installed with the Apache web server. In fact, I went ahead and modified the web pages that are displayed by these two instances. So the first web server at this DNS address, this is what it shows. It says web server 1, this is web server 1. Similarly, the second instance on the other DNS address shows this message, web server 2, this is web server 2. This is just for us to identify and to ensure that our ELB itself works well. Back to the web console. In order to create an Elastic Load Balancer, it's quite simple. All we need to do is go to the Network and Security tab and click on Load Balancers. This is the GUI method to create a load balancer. And of course, you can use the AWS SDKs in Java, Python, or any language to create the load balancer as required. So click on the Create Load Balancer icon within the GUI. You need to give a name for the ELB. I'm just going to say ELB Demo. We'll say that we create this inside the default, network. And this is going to be a simple load balancer, so we're just going to ask the load balancer to forward all incoming requests, HTTP requests, on port 80 to the instances on the same port. If you want, you can change the external ports and the internal ports depending on your application. Since we're just creating a simple HTTP web load balancer, this is all we need. So let's continue. It's also going to ask you what your health check is. We have only one page on our web server, which is index.html, but this could be any page or any kind of path in whatever kind of protocol that you want. We're just going to keep it as this ping, and it also is going to ask you what your health check timeout is. So if a server doesn't respond within 5 seconds, it's going to assume that it's not responding, and it'll temporarily remove it from the pool until it comes back in another health check. And it's going to conduct health checks every 30 seconds. And I think if a instance fails 2 consecutive health checks, it'll be removed from the pool. And if it passes 10 consecutive health checks, then it would be reintroduced back into the ELB pool. Next, it's going to ask you what security groups you want to assign. I'm just going to give the standard SSH HTTP security group that I already have. Now it's going to ask you to add instances to the load balancer. So we're just going to add these two. As you add the instances to the load balancer, it's also going to tell you which zones they're in, and you can enable cross-zone load balancing if required. It's probably not going to affect us because both of these instances are in the same zone. Since all of these things look okay, let's continue. It's also going to ask you to review before creating a load balancer. So let's just go ahead and click create. Now in the load balancers page, your load balancer should show up. It typically takes a few minutes before the load balancer is active because it has to perform the health check on all of the instances that are part of the ELB. In fact, ELB is going to show that your instance is out of service. Just be patient. It'll take a few minutes before this is actually active. Once the ELB is active, it should forward the traffic appropriately. Okay, now that the instances are now in service in the load balancer, we can test this load balancer out to make sure that it's working. You should be able to get a DNS name of your load balancer, and if you visit that in your web page, assuming that the load balancer is forwarding HTTP requests, it should send it to one of the 2 web servers. So right now it's sending it to web server 1, and if you refresh it enough number of times, you'll see that sometimes the requests are forwarded to web server 2. So that's the basics of just setting up a simple load balancer to forward HTTP requests. Of course, once everything is said and done, you need to make sure that you delete all of your resources from AWS once you're finished working with them. So let's just go ahead and delete this load balancer. And do not forget to also delete the instances that are running behind the load balancer as well. So deleting the load balancer itself is not enough to get rid of the instances behind it. You want to make sure that you delete both the load balancer as well as the instances that are running behind it.